Figure 6 shows a graph y equals to fx, where fx is equal to 2x plus 5 times x minus 3 all squared. We have to find the values for x, for which the graph fx is smaller than or equal to 0. We can write it as 0 is smaller than or equal to 2x plus 5 times x minus 3 all squared. You get x is smaller than or equal to negative 5 over 2, or x is equal to 3. If you're not sure, you could check the graph. The 2 points where the graph crosses the x-axis are when x is negative 5 over 2 and when x is equal to 3. You have to write x is smaller than or equal to negative 5 over 2 because the graph extends beyond the x-axis downwards. And x is equal to 3 because it just touches the x-axis, where the graph fx is 0. Part B needs you to expand fx into the form ax cubed plus bx squared plus cx plus d. First, expand the term x minus 3 all squared into x squared minus 6x plus 9. Then multiply the remaining two brackets together, resulting in a cubic expression. Simplify the equation by grouping the like terms together. At the end, you get fx is equal to 2x cubed minus 7x squared minus 12x plus 45, where a is 2, b is negative 7, c is negative 12, and d is 45. The curve crosses the y-axis at point P. When we find the coordinates of P, we can simply substitute x equals to 0 into the expanded equation from part B. Fx is equal to 45. The x-coordinate of P is 0, and y-coordinate is 45. See part 2 asks for the gradient of a curve at P. If you differentiate the equation of fx once, and substitute the x-coordinate of P into the differentiated equation, you could get negative 12 as the gradient of a curve at P. Now onto part D. The original curve, y equals to fx, is translated 2 units in the positive x direction to the curve with equation y equals to gx. On the right, I've got a table for the transformation rules of functions of the net. For this question, we use the function that is stated on the 4th row of the table, f brackets x minus c, to express horizontal translation to the right by c units. You first write down the original function fx before translation, and you do f brackets x minus 2, as the question is asking for the translation to the right by 2 units. Expand the equation into gx equals to 2x plus 1 times x minus 5 all squared, using the answer from D part 1. Substitute x equals to 0. X is equal to 0 because the question needs you to state the y-intercept of the curve with equation y equals to gx, and the x-coordinate here is 0. You get an answer of 25, which is the value for the y-intercept.